The topic of this video lesson is finding the standard deviation from a frequency distribution table. Example 1. Pizza is a very popular discretionary expense for high school students. The table below shows the number of times the 80 seniors at Smithtown South High School visited Smithtown Pizza Pals in August. Find the standard deviation. Round to the nearest hundredth. All right, so remember the first step in finding the standard deviation is to find the mean. Now what we see here in our data is that this table shows the number of visits and then the frequency, so the number of students that had this number of visits. So for example, in the first row, we could see that 12 students visited just 5 times in August. 21 students made 10 visits. 8 students made 12 visits each, and so on. So in order to find the mean, we need to first find out how many visits altogether took place. So we're going to be taking the number of visits and we're going to be multiplying those by the frequency, right? So we're going to say in this first column, we're going to call the number of visits our data points or our x sub i's. And then of course our frequencies we're going to just denote with the variable f. So in this column here, we're actually going to take our x sub i's and we're going to multiply by f. I'm going to go ahead and center that. And then I will change the color a little bit later on so that it matches the rest. All right. So in this first column, we're going to take the students that visited 5 times each, and we're going to multiply by how many students, which in this case is 12. So I'm just going to use the formula. And we're going to do the same for the second row and the third row. And all I'm doing, as you can see, is just multiplying the 2 cells. And remember, when we type in formulas, we have to put equals first. And each of these is going to tell us how many unique visits occurred. All right, now if we look right here then, and I want to figure out how many visits altogether occurred, I'm going to use that equal sum formula, right? Remember, which adds all of these, and I'm going to select all the cells that I'd like to add together. And I could see then that there were 960 separate visits that took place. All right, let's see if I can match the font and the size. So I have here Calibri 24. Good, so it matches the rest. All right, so this just tells us our total. Now, ultimately, I want to find the mean. Now, remember, the mean is the total divided by the frequency. So I want to put the mean right here, and I'm going to go ahead and just label it mean. That way I don't forget later on. And then in the cell to the right of where I've written mean, I'm going to put in the formula. So I'm going to take this 960, which is in cell D13, and I'm going to divide it by the total. And I can see here that the mean is 12. Okay, now once I have the mean, I am then going to find the difference, right? So if we remember from before, we need to take x sub I, and we're going to subtract x bar. And I'm just going to write for the sake of this right now, since I don't have easy notation. I'm just going to write x bar, but do remember it's just an x with a line above it if you're writing it out. Right? I'm going to change these all to that same font and same size, just so that it matches. All right, so I'm going to take my mean, which was 12, and I'm going to subtract it from each of my x sub i's. If I look here, this is my x sub 1, and I'm going to subtract my mean, which is down here in cell E15. And then I'm going to do that for every single one of these. And I'm going to find the difference between each data point and the mean. All right, I'm going to keep continuing that until I have them all done. And this is just the difference between the mean number of visits and the number of visits for each row. All right. All right, so now once I have those differences, I then need to square those differences. So I'm going to do x sub I minus x bar, and then I'm going to square it. And that's going to give me those squared differences that we talked about in the last lesson. All right. Okay, so in this case, here I already have my x sub I minus x bar. So I'm simply going to take this cell and square it. So let's go ahead and let's take that -7 and we're going to square it. Then E8, which is -2, and we're going to square it. E9, and we're going to square it. And you will notice here that squaring is just the caret key, so shift 6, and that means to the power of, and then a 2. So whenever you want a power, you use that caret key, that shift 6. And it will simply multiply the number by itself or square it. All right, so now we have all of our squared differences. Now, once we find the squared differences, we need to multiply each of these squared differences by the frequency that they occur. Because remember, right here, this 49 is the squared difference for only one person's visit. And we have here in this row that 12 people visited 5 times each. And so in this last column, we're going to take that x sub I minus x bar squared, but then we're going to multiply it by the frequency. So we're going to account for all 12 visits. And I'm just going to do quick formatting here to make sure everything kind of looks similar. Just make that a little wider. All right, so the cool thing is we already have the bulk of this expression completed. We have the x sub I minus x bar squared in column F. And so we really just need to multiply each of the values in column F by their frequency. So we're going to go ahead and let me just make sure my formatting looks good. We're going to go ahead and just take what we have in cell F7, which is the 49, and we're going to multiply it by how many there are, which is 12. And I'm going to repeat that process for each row. So I have equals, I have my squared difference between the data point and the mean, and times the frequency. And repeat, and repeat, and for the last one, repeat. Now, each of these will now show us the difference between the data points and the mean squared, but will account for the fact that we have this many of them, right? We have 12 of the first one, 21 of the second one, and so on. Now, remember, in order to find the mean of these squared differences, we have to then find the total. So we're going to create another total, and we're going to find the total of all of these values right here. All right, so we're going to just use that equals sum. So we have equals the sum, and then we're going to find the sum of all of those squared differences times the frequency. And we could see here that we got 1,134. Now, remember, in order to find the mean of the standard, well, not the mean of the standard deviation, basically the variance. In order to find that, we need to take that total and divide by the total number of frequencies. So we're going to take that total and divide by the total number of frequencies, which was 80. All right? So that there gives us the variance. Now, we don't want just the variance. We want the standard deviation. So if you remember from before, in order to get the standard deviation is the square root of the variance. So I'm going to put right below the variance, I'm going to put standard deviation. I'm going to take that cell above it. And at first I'm going to type equals, and I'm going to type square root, which is SQRT. And then I'm going to highlight that cell that we got for the variance. Now, I really only want the standard deviation out to, let's say, 2 decimal places or the hundredths place. So I'm going to just decrease that place value. And I could see here that the standard deviation is 3.76, which answers our question. All right, so now it's your turn to try. Let's try this. Donations to charity are discretionary expenses. In a class of 30 students, 6 students donated $5 each to Relay for Life. 15 students donated $10 each, and 9 students donated $20 each. Find the standard deviation for this distribution. Round to the nearest hundredth. Okay, use what you just learned, create your frequency distribution table in Excel, and follow the steps. Submit your answer to Canvas when you're done.